In this video, I'm going to create SQL cluster in Linux environment. Before we create the cluster, we need to understand what is SQL cluster and why do we need it. I'm not going to go too much into the SQL clusters, which will take a long time, but I'm just going to give you a brief idea of what is the cluster and why do we need it, and then move on to the SQL Linux clustering. Let's say you have standalone database server and this is your application server, and you store the database files in SAN storage, not in the local drives. You don't want to create the database in local drives. You wanted to put the database files in a separate SAN storage. Okay, and your application server connects to the database server to get the data or inserts and deletes, whatever it is. And if this server goes down, so what do, right? It can, the hardware failure or something happens to the database server and the database server can crash. There could be many reasons why it crashed. So if it crash, how do you continue to run the business, right? How do you bring the database up? So what you may have to do in this scenario is build another server, or if you have another server ready, then you got to install the SQL server and then attach the databases or restore the database from this backups. You got to do whatever it is, right? And then connect your application server to this new database server. That's how you bring the database again back online and continue the application. So that is why you need to have a high availability solution, a clustering mechanism in place. If one server goes down, you should be able to use the other server to access the data. So in cluster, what do? You build two servers instead of one server. You build two servers. This is node A and this is node B, and you create a cluster of these two nodes, and you put a name to the cluster. Let's say VSQL, and in the application server, you don't specify node A or node B. You don't specify that. You specify the cluster name, and the cluster. Let's say you are building two node cluster. Only one node will be active, and the other node will be passive. Whichever the node that is active, that will be processing the database. The database instance will be running on the active node. So when you connect to the virtual the cluster name, and then it routes the database requests to the active node, and then this node gets the data from the files and then process it and then sends the data back to the application server. That's how it works. So if this server goes down, and let's say this is your active server and it goes down, then the other server, the other node, which assumes the role of the active, okay, and this will become active server and then starts processing the request. So in case of failure, so other node will start processing the request because the the data is not local to the servers. So the data is outside the servers. So this server will start connecting to the database server, the storage, and then the services fail over. A lot of things will happen. Okay, and this server will become active, and this will start processing the request. So you have a minute or two of failover time, because when one server goes down, it will take a minute or so to failover the services to the other node, and that's it. The next minute you have the database up and running. If it is a mission critical application, clustering, I would say, is very important. You need to have a cluster there. If one server goes down, the other server will start processing the request. So that is why we need to focus more on the clustering mechanism. So SQL Server cluster is a high availability solution. Okay, so you can also use always on. Always on is a high availability and disaster recovery solution. So, but typically you use a cluster for high availability solution. Okay, so that is the cluster concept. In this demo, what I'm going to do, I need three servers. Since I don't have SAN storage, what I'm going to do, I'm going to create a server, SQL sent OS1. You can see that here. I'm going to create that server and then install the Samba server to create the SMB shares, So if I install the Samba server, I can create the share folders. We can see the share folders here. I can create the share folders and I can put the data there, and then these nodes will access the database in the share folder. Okay, both nodes can see the same share and can access the database. Both nodes can see at the same time. Unless Windows Server failover cluster, when you install the cluster and create the SQL cluster, you see that whichever the node is active, the resources are available on that node. But here we don't have the SAN storage. Probably if you have SAN storage, we could have done the same thing where we can present the storage to the just to the server, whichever is not active. But here I'm going to use the SMB storage. Here the instead of SAN storage, I'm going to use the Samba storage. I can use NFS or iSCSI or whatever it is, but I chose SMB shares because I'm familiar with that SMB share concept. So I'm going to use that SMB shares, and I'm going to put the databases on the SMB shares on this server, and I'm going to configure the database engine that is running on each node to access the database files in the SMB share. Okay, so that's how I'm going to set up the SQL cluster. So to create the cluster, these are the steps. First, I need to install SQL Server on these two nodes. After installing the SQL Server, what happens is it creates the files and then folders in the default location where OPT, MSSQL, data, log, whatever the default location, the SQL Server I'm going to configure, it is going to be there. And then once I install, I'm going to shut down the SQL Server on both nodes. Once I shut down, what I'm going to do is I'm going to take whatever, see, when I install SQL Server, it creates the master database, MSDB, TempDB, all that stuff, right? System database. Similarly, when I install SQL Server, it does the same thing. Master database, MSDB, TempDB, in where OPT, MSSQL data folder. After I install the database on these two servers, I'm going to shut down the SQL Server. And then what I do, I cut these files, move the files from here into the share folder, and then I'm going to delete these files. But the SQL instance is still there. I'm just removing the files in the data folder. Okay, and then move those data files to the share folder. And then what I do, I have to disable the SQL Server on both nodes because these two nodes are going to access the same data. What I'm going to do, once I copy the database files, I'm going to copy the server master key to this server. Okay, because in the cluster, both server access the same data. If I copy the files, the master database file, system database files from this server into the shared storage, and this instance, it is going to access the same files. It cannot use the server master key to access the same files, right? So that's why I got to copy the server master key from this server to this server, and then when I start this server, and then it's going to use the same master key to access the files. But these two servers, okay, these two servers can see the data at the same time. So you should make sure that the SQL server should not be running on the two servers at the same time. It can corrupt the data. At any time, only one server should be active. So when you install the pacemaker, pacemaker is like a Windows Server failover clustering software in Linux environment. When I install the pacemaker to create the cluster, I'm going to add the SQL servers as a resource. Then pacemaker will start accessing the SQL server, and it is going to bring the SQL server and the data share location as well. Okay, so and this is my cluster name, and your application server will use this cluster name to connect to the cluster. So these are the IP address I'm going to use: 111 and 112 and 110. So you have the two nodes here, and the SQL service, the engine, will be running on these two nodes and accessing the data from these share folders. So that is what we are going to do. Okay, let's proceed installing the the cluster. When you install the Linux on these nodes, make sure you select this option, high availability. Or if you are installing via command prompt, you may have to install that high availability add-ons to the cluster. So this is important. This is a requirement. I listed down all the important steps in this cheat sheet. So everything is important. You miss any one step, that's it. You will be stuck and you will be scratching your head. When you install the Linux on these two servers, just make sure you install with high availability option here. But when you are installing the SQL Server on a standalone, you don't select this option because you don't need this add-on to the server. On this server, I'm not going to add on the high availability because the SQL, it doesn't, that server doesn't need it. It's just going to host the database files. If you are following Microsoft manual, there is an online manual. So if you are following the manual here, what Microsoft says is you create the NFS share or SMB share on this server. What the manual says is this: you create two servers and then you create the NFS shares here and then create the cluster. But if you create the NFS shares or SMB share, whichever share, on any one of the node and you bring that node down, then what happens? The server goes down, the share goes down. Forget about the cluster, right? That's not going to be possible. That's why what I did, instead of, I followed pretty much what is here, but I just took a little deviation. Instead of creating the share folder, the database files on any one of the node, I have put these files in a different server. Okay, if you have the share folders on even Windows server, you can access those share folder from the Linux server, right? So basically, that share folders, that's where the data is going to be. That has to be outside the nodes. But if you're following the Microsoft manuals, pretty much some of the steps that I'm going to do is not there. Okay, I took little deviation. I put the data in a separate server. So I don't need to install the high availability for this shared storage, okay, on this server. But for node A and node B, I need to install with this high availability. Okay, so what I did, I have created node A and node B and even this server, and I have installed SQL Server on both the servers. Okay, that's what I did. That's a so start with that. Okay, so I have already completed this part. I just installed the SQL Server on these two nodes, and now I'm going to do the rest of the steps. So I have listed pretty much, I got stuck in many places when I'm following this manual. There are some permission issues. I need to put some labels, or some steps are missing. I have to figure out so many things. Sometimes it doesn't say clearly on which node to execute, things like that. That's why I have pretty much written whatever we need to do. Sometimes if you see somewhere I might have said you need to perform this step on both nodes. Okay, so that means you really have to do it on both nodes. If you forget to do it on other node, that's it. You don't know what is going on. And moreover, it's Linux server. You will be searching the files and I don't know, good luck. Okay, so you got to exactly follow what is here. There are some mistakes in this manual, not mistake, I would say missing points. Let's create the cluster. So I have already installed the SQL Server on both nodes. Now on secondary server, on the primary server, I have installed the SQL Server on both nodes, but I didn't disable it yet. I just left it. Okay, before I start the demo, I don't want to start from this really from the scratch, begin installing the Linux servers. That will really take the video 1-2 hours. So that's why I created the nodes and then completed up to this portion. So on the secondary node, we got to disable the SQL server. Right now, the two servers, the SQL servers are up and running on both nodes. Okay, so we got to stop the SQL server on the node 2. Let's copy this line. This is my 110. You can see from here 110 is my share storage, and 111 is node 1 and 112 is node 2. So this is my node 1 and this is my node 2. So database is running and database is running here. So let's stop this one and disable it. Okay, and then go to the node A. We got to put this in the etc host file because I'm going to use the CentOS1 and I'm going to use CentOS1. For example, if I say SQL CentOS2, it cannot resolve. But if I say 192, 168, 56, 112, it can ping that server. Okay, so it cannot resolve the DNS names because it is not connected, or there is no name server. Okay, it is not joined to any DNS. So that's why I got to use the etc host file, and I'm going to put all the DNS entries here. So if I say, so I'm going to use all the names, the DNS names here. So now if I say CentOS2, it can ping that IP address. Okay, so do the same thing here. Okay, that is prerequisite. And then since okay, I think we got to stop the master. We don't need to stop. We need to copy the server master key from this server to the this server. So this server is right now active. The SQL server is running, and we just disable the SQL server on the CentOS2 server. So we got to copy the server master key onto the secondary server. The server master key is located in this folder. So I have the server master key here. So what I'm going to do is okay, I just copied this machine key, the server master key in this one. I copied this from the CentOS1 server, no, from node A. So I need to change the ownership. Okay, I did this step, and then I copied this, and then okay, so yeah, let's change the permissions to 600. So earlier it was this, and now it is yeah, I think pretty much it's same. We didn't do anything different. It was 600 and now we changed it back to 600. Okay, all right. And then now let's start the primary server. I think it is started. We didn't stop this server before we. Yeah, probably it's better to stop and take the copy of server master key. I don't want to take risks. So we'll start MSSQL. I'm going to do the same procedure again because I didn't stop the SQL server before I copy the server master key. I'm going to redo again. Okay, so I just copied. Now let's start the SQL server on node 1. All right, it's running. What we have to do is we have to create a login for the pacemaker. Pacemaker is it's like a Windows cluster software. It manages the resource. When you create the cluster on Linux, basically you are using the pacemaker and CoroSync. There are two softwares, the packages that you use to create the cluster. The pacemaker it manages the resources. Okay, it's like a cluster resource manager or something like that. And the CoroSync it just communicates between the nodes and just make sure both nodes are alive, stuff like that. So you use the pacemaker and CoroSync to create the cluster. That's what you need to remember. So that the pacemaker software it connects to the database instance to move the database instance between the nodes. Okay, it needs the cluster software. It needs access to the database. So that's why we need to create a login for the pacemaker. And then when we are creating the cluster, we specify these login credentials. So since we have started the SQL instance on the node A, I call this as node A, CentOS 1, and then CentOS 2 as node B. So let's connect to the server. And I'm creating the pacemaker login and assigning SA permissions for that login. That is what Microsoft manual says. Instead of assigning so many permissions, why don't you create sysadmin? Okay, so that's what I'm doing it here. So the pacemaker is created with sysadmin login. And then we got to stop the database on the node A, the SQL CentOS 1. And then disable it. So now at this point, we have disabled the SQL server service on both nodes. And we copied the server master key from node A to node B. Okay, that's what we did so far. Now what we have to do is we have to configure the storage and move the now we have to configure the storage. That means we have to create the share folders on the SMB storage and move the system database files from node A into the share folders, and then delete all the system database files because we don't need it, because both instances are going to use the same system database files. So that is why we are going to drop or delete all the system database files, and then we copied the server master key here, because using the server master key both nodes can access the system database files which is on the share folder. Okay, so first we have to we I created this server, but I haven't configured this server. Now we got install the smb the samba server and create the share folders, and then move these files. So first let's configure the share folder. So that's what this step says. So on this share fold the shared server, the SQL sent OS share on this server, we have to disable the firewall. I guess I might have already done it, but let's check. So this the firewall is running. So stop the firewall and then disable the firewall. Just make sure the firewall is disabled on these nodes, because for this demo I don't want firewall to be running. So it is disabled here. It is running here. So let's okay, I don't have firewall on any of the three servers I'm dealing with right now. So I'm going to create a user. We need the Linux user on the storage server. Okay, so I'm going to use MSSQL, this account. You can create any other name, but in this case I just selected MSSQL. So we need to create this on the storage server. So you can see what is that user details. Okay, this user is in this group and etc etc. Okay, all right, so we need to install the Samba server. We need to install the Samba server, and Samba client is not really required, but it is there in the manual. So I'm going to install the SMB storage. All right, I just installed. Now we need to create the folders for the shares. Let's navigate to this folder. There is no MSSQL. Okay, so let's create. So in this directory, let me go back here. So this is where I am going to, in this share, I am going to put the system databases. And in this share, this is my default data files. And this share is going to be a default log files, SQL log files. And this one is going to have SQL backups. Okay, the four shares I'm going to create. And in this share, there is a subfolder. There is another folder log where I can put the dump directories or the error logs or whatever it is. You can put the system databases directly under this folder, and any log files or whatever it is under this folder. Okay, but this is the share. So now let's create these folders. So it changed from root to MSSQL. And then the share folders, let's give full permissions. So you can see here the permissions are changed. The reason why I have given full permissions, I don't want any issues with permissions, accessing the share folders from the clients and stuff like that. But if you are really going to work seriously on clusters, you have to restrict the permissions, not to open up everything to the clients. Okay, so start with the minimal permissions, minimal permissions, and then move on to giving more and more rather than opening up everything else. So you can see here. I have these 4 folders. This is my shared storage. Okay, I'm going to put all my shared storage in these 4 folders. Okay, so now we got to configure the SMB. Before we access the SMB shares, this is how we configure. So there is SMB under the Samba folder. You have to create the configurations. So by default, it has the basic configurations. This is the global. So this is global for all shares. Okay, so and these are the some of the shares. It comes with installation. Now we are going to add our own shares. All right. If you have followed my previous video log shipping, I explained some of the options. What are these? I'm not going to go through in detail. I'm going to create what I'm saying. All I'm saying here is okay. I'm going to create 4 shares in the SMB. And then the Samba share, uh, it has been configured. If a client, see here, these 2 servers are going to access the share folders, right? So these 2 servers are clients, and they connect to the share folder and access the files there. So when we create the share folders, we set up the credentials. Whoever is going to access the share folders, they need to authenticate. Okay, so we are going to set up the credentials for the share folders now. So these clients has to use the credentials to access the share folders. Okay, since we are configuring the share storage now, we got to create the credentials. So we are now, that is what we are doing now. We are creating the user in the SMB share. So for this is the command. Okay, you got to use SMB password, and this is the local user account. They don't confuse with the Linux user account. This user account is different. This user account is for the SMB access, SMB server. Okay, it is different from the Linux user account. Okay, you can give anything you want, MSSQL 123 or anything. Okay, I'm kind of given the same username all over the place and password same all over the place. Sometimes you might get confused. Okay, which username, which password, for what? But you can play around, give a different account and see how it behaves and what it says. So since the purpose is SQL clustering, everything is MSSQL. So I have created wherever the user, whatever the user, MSSQL and password everywhere is admin123, just to make my life easier. Okay, but if you are working in production environment and seriously implementing Linux clusters, you got to give different passwords and permissions. You have to be really careful with these things. So I'm going to create SMB credentials now. Okay, now let's restart the SMB server and NMB. I don't know much about SMB or NMB. All I know is okay, it is a server where we can create the share folders. Okay, so more than that, I don't know nothing much about it. That's what I'm doing it. Okay, so we got to enable these SMB and NMB services because when the server reboots, it will bring these share folders. Otherwise, it doesn't bring these share folders. Okay, so when you enable, so it creates a symlink in the appropriate unit folders to start the services. So firewall we just disabled, we stopped and disabled, so we don't need to add this. But if you have internal or external firewall to this server, you may have to add the Samba service. Okay, so see, now we have we configured the SMB, right, the Samba share. So we can see, show me the shares. These are the shares that we have created, right? It is available. And Linux server, this is specific to CentOS operating system. It may not be applicable to other Linux flavors like SUSE Linux or some other Linux, I don't know. But for the CentOS, this is not there in the MSSQL, the manual, in this manual. Okay, so I got stuck here and I was searching Google for some time to figure out what is going on. So we need to set the labels for every share folder. Sorry, it should be 4 directories. And now we need to give read write permissions to those folders for that MSSQL user. I can just block everything and paste, and I don't know if I miss anything or if it doesn't work for one of the things, then we will be banging our head. So that's why I'm carefully copying one by one just to make sure not to miss any single line. All right, now we have set appropriate permissions for the share folder, and then we are ready to rock and roll. So let's access the share folders uh, from our um, from our nodes, the SQL CentOS and CentOS 2. So before we access the share folders, we have to install the client components on nodes. So let's run this command on this node. Okay, we can access the internet. So what it is doing is it is downloading the packages from internet, and then it is installing it. And we need to have internet connection. If you don't have internet connection, you got to download this package and then this package, okay, and then maybe these packages. You have to download all these packages manually and then install the dependencies first and then install the actual ones. Okay, so you got to do that. So if the server is connected to internet and you have the repositories, then voila, you just install Samba. That's it. It's going to retrieve whatever the dependency packages and it's going to install it. Sometimes, if you have internet connection, things are so easy. Now we have installed this, so we got to install this on the other node as well. Before we install, make sure we can access the Google. Okay, all right, let's install. All right, now let's access the share folders. You can see here I'm able to access the share folder. Good. So it's good. Now we are able to access the share folder. Now we can see the share folder. From the nodes, it can see the share. But to access the share, you need to create the credentials. You need to specify the credentials. So far, what we have did, we have created the shared storage on this server. All right. So now next step is move the database files from SQL CentOS 1 to the storage. Okay, so when we install SQL Server, we got the system database files in where opt MSSQL data folder. Okay, so we got to move those from the data folder and paste it in this share folder. And once you can do that on any one of the server, either this server or this server. If you are doing it from this server, for example, you are moving the system database files from this server to the share folder, then you got to copy the server master key from here to here. Since I copied the server master key from node A to node B, I need to move these database files to the share folder. So that's what we are going to do now. So on SQL CentOS 1, which is node A, I need to, it says I need to disable the firewall, okay, which we already did. Make sure the SQL server is stopped. Okay, it is stopped here. And how about here? It stopped on node B as well. And then we got to connect to MSSQL account. See, the reason I said SU here, if you are connected to Linux server with any other account, for example, SQL server or any other user account other than root, you have to first switch to the root or sudo as a root, and then from there you connect to MSSQL because it's a passwordless account. MSSQL there is no password, but you have to connect to this account to do some things, okay, to copy or do whatever it is. Okay, that's why I said since I have already logged in as a root, I don't need to perform this step. Okay, so all I have to say is MSSQL. Now you can see I have logged in. I have changed my account to MSSQL. Now we need to create. Okay, now this is just okay. We got to create this folder under MSSQL. So now we are in that folder. Just create a TMP folder. Okay, so we just created this folder, and now go to this data folder, move everything from here, TMP folder. I think that's what my next step is here. Copy everything uh, from this folder to this folder, or you can directly move whatever the files here to here. Okay, so that's what I'm doing it. So there is no files here now. So all the files are here now. Okay, so all my system database files. I just because I'm going to, where is this data? Okay, I'm going to create a mount point on the data folder to this share. Okay, when I create mount point, this mount point, this directory, where is the directory? Okay, this directory is going to point the share folder. Okay, so you should not be having anything there. That's why I just moved everything from this folder into temp folder. Once I move the files, after I mount the share folder, mount the folder again, I'm going to copy the files from TMP to the data. So that's what I'm going to do next. So I'm going to create the other folders here. So let's, okay, so here, okay, we did this. So we, yeah, since Microsoft SQL Server Service is going to access these folders, so the SQL Server Service running under MSSQL account, that account should be owning these directories. Otherwise, it cannot access these folders. That's why I got to switch back to root again to create the folders, because the MSSQL account doesn't have access to create the folder directly under the root partition. So I got to switch back to the root here, and then create these folders and change the ownership of the mount point so that SQL service can access the mount points. That's what I did. So these steps are missing here. Now we have to create the credential files for SMB share. So let's all right. This is just to make sure the root owns this the SMB configuration file. And then now let's mount it temporarily. The way the command here, you are mounting these share folders to these local directories. Okay, you are creating the mount points. So when you reboot the server, these mount points will go away. I'm just going to create the mount points temporarily to copy the files. And then you have to, you can see here, it mounted these four folders. All right, now we got to, so if you, this folder is now mount point folder. Okay, so if you go here, there is nothing. Or there is a log folder. We created the log folder here. So that's why we are able to see that log folder here. So let's see if we can create some text file. Yeah, we can create some text files. And then let's, all right, we can remove the text files here. Now let's copy the, so we copied the system database files to the share folder. Now let's list it here. Okay, on the storage server, we have these files now. And then now let's start SQL Server. Okay, the SQL Server is running and it is disabled, very important. Now the SQL Server is accessing the database files, the system database files on the share folder, but this directory is a mount point to the share folder. Now let's connect, just to make sure we can connect. You can see here when I say select server name, it shows the local server, because when I install, it just takes a server name. It shows SQL CentOS 1. But after installing the cluster will log into the SQL service and then change the server name to the cluster server name. So that you will observe later. It does a couple of things inside the database. But I just want to show you, before I create the cluster, the SQL service, the database, it has this SQL CentOS 1 on this node. Now we got to stop the SQL server. Okay, now the status is it stopped and disabled, which is good. Now we have to configure the SQL CentOS to the node B. There is nothing much to do other than just creating the mount points, because we don't need to copy the data, because the SQL instance, it is going to use the same system database files on the node A, which is really on the shared location now. Now all we have to do is just create the 4 mount points. That's all we need to do. So we have stopped and disabled the firewall, and and even this is the SQL server is stopped, I guess. Let's run this again. Okay, it is stopped and disabled, which is fine. Now let's connect to the root. We already connected to the root. Switch back to MSSQL account. Create this. Of course, I think the same problem. MSSQL cannot create. Exit back and then create from the root. Now we can remove the files under the data folder. So before we remove, let's create some temporary folder. Okay, we have all the files in a TMP folder. Let's switch back to root and then set up the credentials for SMB share. Now let's mount the before we mount it, just wanted to make sure. Okay, the MNT here, the mount point is here. I just want to make sure the three folders are there. Okay, we got the three folders here. All right, so now let's create the mount point. We created the mount points. You can see from here the mount points here. So df minus h, it's already there. And then we got exit from the root account, verify that SQL Server starts successfully. Okay, so with the SQL Server here, it is stopped. Okay, now we configured the share folders here. If we start the SQL Server on node B, it is going to access uh, the share folder which has the system database files of node A, and it should show the SQL sent to OS1. Okay, let's it's running. it shows SQL1 or SQL CentOS 1 because these system database files are from SQL CentOS 1, right? So we can access it. Now we got to stop the SQL service, and it is stopped and it's disabled. Okay, that is very important. Now it's time to install the pacemaker. That is the cluster software in the Linux. Okay, the pacemaker is just a cluster resource manager software, and this is like a WSFC in Windows Server. Okay, so on both cluster nodes, we have to create this the credentials for the pacemaker. So we have created the SQL login for pacemaker. If you remember one of the previous steps, we have created the SQL login and we assigned the SA permission, right? So we are going to use that credentials now. We are going to create a credential file and create the, set up the credentials for accessing the SQL server. That's what this step is about. It says that, okay, create a file and put the username and password and assign the proper permissions so that for the file, for the credential file, so that pacemaker can use the credential file to log into the SQL server. Okay, so that's what it is. So now I'm going to copy all these steps into my notepad. So we need to do this on both servers, SQL CentOS 1 and CentOS 2. When you say touch, you are just creating a blank file. Okay, that's what the touch means. Okay, so we got to do the same touch on the other node. We forgot to do it because we have to do on both nodes. Okay, so that is what we did so far. We just created a file with 2 lines in it. All right, so we have created the credential files on both nodes. We have to open the pacemaker firewall ports. We don't have the firewall running, so we don't need to do this step. So our next step is to install the pacemaker and then corosync whatever the cluster software on both nodes. Okay, so run this command. This will install pacemaker, PCS. This is a corosync, I guess, and then fence agents, all and resource agents. This line is there in the Microsoft manual. I just copied it. So just run this command on both servers to install the cluster software. We are not creating the cluster. We just install the cluster software. So it says the pacemaker, whatever we are trying to install, it is already there. The reason is, I think, since we selected this high availability option, it created all the cluster related packages with the Linux operating system. These are the additional add-ons that we have selected while installing. That's why when we install the pacemaker right now here it says, okay, those packages is already installed, so you don't need to do anything, nothing to do. So yeah, same thing here. Okay, so which is good. We already did it earlier. Now we got to set up the password for the pacemaker and corosync packages. So we have to run this on both nodes just to make sure. Okay, so now we have to enable the PCSD service and then pacemaker because when this cluster, sorry, the nodes, when they rejoin to the cluster after the reboot, it has to automatically start these services. So most of the services that we are dealing with, as part of cluster installation, you have to keep it enabled other than the SQL Server service. Okay, so I did it. Now we have to install the failover cluster instance agent um, for the SQL Server on both nodes. Okay, so we got to install this additional package, Microsoft SQL Server High Availability package on both nodes. So now let's install. The repository for this package we have already downloaded. When I'm installing the SQL Server service, the repository it has this package, so it is using from that package. You can see that. Okay, I'm going to use the database repository to install this HA. All right, so it's done. Now it is time to create the cluster. Okay, so we are almost near the climax. Start the cron service. I don't know why we need it, but I have read this in one of the forums that we need to start the cron service. I don't know why or how this cluster uses this. This is not there on the Microsoft manual. I read it somewhere and I just included as part of my cheat sheet. So nothing, it's not going to harm anything, but I don't know why we need to do it. I'm just doing it. Now this is how you authorize the two nodes to join the cluster. So you just have to run it on one of the node. That should take care of joining all the nodes. So you have to specify whatever the nodes that you are configuring and how you are going to be authorized. Okay, so here I'm going to create the cluster, not cluster. I'm going to use this authorization HA cluster. We have already created earlier the HA cluster username and then use the same password. And then now you create the cluster. So here the cluster name is Linux cluster, and then these are the nodes. Okay, we created the cluster. Now we are going to start the cluster on all the nodes. Now we got to enable this cluster when the node is rebooted, so it will automatically join. So this is one step we have to do. And to verify the status of the cluster, this is one command you use very often after you install the cluster. Whenever you move or set any constraint or any you do anything in the cluster, you just make sure what is the status. Okay, so when we say cluster status, it says okay, this is the cluster name, Linux cluster. It says no Stonith devices is configured. Okay, of course you are going to install, you're going to Set the cloned device next, and then it says, okay, Coros sync status is this server SQL sent OS2. It has the quorum, and the two nodes are configured, and both nodes are online. And then it says, okay, these are the daemons, the Coros sync, pacemaker, PCSD. All these daemons are active and enabled on all the nodes, so we are good. So there are no error messages or anything. The Stoneit is we have to use Stoneit in the production environments, but for the demo, I'm not going to use the Stoneit. Stoneit is a method. It just isolates the node when it becomes unresponsive. If it goes down, or for some reason, if it is not active or something wrong, it just remove that node from that cluster. Okay, since I am not going to use any Stoneit. So what is, the Stoneit stands for shoot the other node in the head. Okay, pretty violent term, but that's what it is. But if you are setting up the cluster in the production, you have to create a Stoneit device. Okay, it could be a share folder or something. It just uses the share folder to isolate the nodes and things like that. And then this CoroSync is just communication between the servers, the nodes. And now we have created the cluster. We haven't created the SQL cluster. We just created the Linux cluster. Okay, so we can. There is a URL you can access. If you go to the server, and open up the browser, and then this URL https okay, so now here you can see this is a GUI in the Linux server to manage the clusters. Okay, we are not going to really manage, but we're just going to see what is there, how you can see some information online without typing many commands. Okay, so I'm just looking at the cluster now. Here, manage clusters. You have to add the existing. You have to enter the name. I enter. Okay, show me the clusters for this node. Okay, it shows there is a Linux cluster installed, and we install two nodes. Click on that. It shows no fencing configured in the cluster because we haven't configured the fencing, which is Stoneit. It says okay, now you can see a little bigger screen. Every node, it has the pacemaker connected, CoroSync is connected, there is nothing wrong. You can see that here. Resources, there are no resources because we haven't added the SQL cluster. When we add the SQL cluster, when we create the SQL cluster, then we will be adding the disks, the resources, right? Everything is a resource there. The disk, the virtual IP, and then the network name. All these resources we will be creating when we are installing, when we are creating the SQL clusters. But right now there is nothing. We didn't create any SQL cluster. We just install the Linux cluster. So that's why there is nothing here. Find devices, there is no devices. Cluster properties, you can see these are the cluster properties. So if you are seriously working on the cluster, you may have to mess around with these parameters. But for now, even I don't know many of them, so I'm not going to explain anything. So manage clusters. it just shows you how many clusters you have here. Okay, you can create the cluster here, create new, and then the cluster name node 1, node 3. I didn't play with this. Probably you can try creating the cluster through GUI. Even there is advanced option. You can do a lot of things here as well. So if I click on it, it shows nothing here. Right, there are no resources. Now we are going to create the resources. Okay, our next step is we got to set some cluster options. There are few options you have to set. One is Stoneit. We have to disable the Stoneit. Okay, we don't want the Stoneit for this demo. So just you can run this on any one of the server, any node, because all the nodes are, you can manage the cluster from any one of the nodes. So setting this parameter from any one of the nodes should be sufficient. So I'm on the node A. You can see 111. So these are some of the parameters. The Stoneit, I'm going to the fencing false. That means I'm going to disable that Stoneit altogether. And then if there is a failure is fatal, no, I don't want to have this parameter. So next is quorum policy. I don't want any quorum. And then the final option is if there is a single failure, just move the resource to other node. In the production, you may want to set two or three. You have to try multiple failures, right, before you decide to fail over. But in the test environment or maybe in the demo, I'm just going to bring down the server or bring down the database instance. If there is a failure, I just want to move resources. Because I don't want cluster to keep trying multiple times and finally say, okay, now it's time to, I just want to see things right away. So I'm just going to set, okay, even if there is one failure, move away the resources to other node. Okay, it's time to reboot these two servers. Okay, don't forget this because I forgot to reboot and things didn't work after that. I was just wondering what was going on, and then when I rebooted, everything is working fine, and then I can continue on to the next step. So reboot the server. Okay, let's restart the servers. PCS status. How is my cluster? Yep, cluster is running fine. I don't see any issues. Okay, anyway, I just connected to the 112 server. Now let's try one more time. PCS status. All right, let's move on to next step. So next, we are going to create the resources in the cluster. Now we are actually going to create the SQL cluster. So what we are going to do is we are doing couple of things extra, not really required. But Microsoft manual says that may be a best approach or something like that. So I just kind of copied those steps from the Microsoft website. Basically, what it says is this is how you create the resource. What you are doing here is you are storing the create resource statements in this file, CFG file. Okay, so basically what it says, queue the changes, whatever changes you wanted to do, put them in CFG file, and finally push the changes in the CFB file into the live CIB. You can directly push the changes into the live CIB, or you can queue the changes in CFG and finally push the CFG here. See here you push the CFG into the CIB here. Okay, so this is one thing unnecessary, but I just copied whatever there is in the Microsoft manual. So here you are saying, okay, start queuing up the changes, whatever you're going to type, create resource, whatever the stuff you're going to create, put them in a file. Okay, so now I'm going to copy this line. These are all pacemaker related commands. Pacemaker and chorusing, it's a big topic. There are many things to know about it. I don't know a lot of things. I just know very few things. just to create the basic cluster for SQL Server. But if you're seriously working in clusters, then you have to know really know about this the pacemaker and the CoroSync software to better understand and manage or maintain, whatever it is. I'm going to create this file now. Um, okay, next step is to create the disk resources. So this is my resource group name. This is like a SQL Server role name in Windows cluster. So I'm creating all the resources. So this is for the system databases, this is for the database, and this is for the SQL logs. And the next one is for the backups. And then you have to specify the IP address. Next is virtual IP. You need to create the virtual IP. That is your next resource. I'm going to use 113 because 110 is a storage server, 111 and 112 is node A and node B, and 113 is virtual IP. And in fact, we have specified all these four IPs in the etc host file earlier. So now I'm going to create that one, and you need to create the network name. You don't really call the network name in the Linux cluster. You call it as a failover cluster instance resource name. That's what it is. This is the name that the application is going to use to connect to the database. Okay, this is the network name. In Windows world, you call this as a SQL cluster name or network name. This is something like that in Linux. So we are going to create that one, and you can set the constraint. So now everything is apart, and we have to set the constraints. Okay, now these all these resources is going to be in this failover cluster instance, something like that. And then you need to set the constraint, resource constraint. What it says is you need to first start the disk resources, and then the virtual IP, and then finally the network name, and then finally the resource group. Okay, that's the order you need to start the resources. Now you can list the resources. This is how you list the resources. Let's see the constraints, whatever the constraints you have set so far. And now it is time to push the changes into the live cluster. Okay, so if you see the cluster now, I didn't execute this command yet. Okay, so let's go to SQL CentOS OS1. Now you can see there are no nodes, right? We added lot, we added the resources, and then we did plenty of things, but we haven't executed the final command push right into the live cluster. But now, since we haven't added, you can see there is nothing here. There are no resources. As as earlier, there are two nodes, just a basic Linux cluster. So when you run this command, it says CAB updated. Now if you go here and refresh this page, you go to resources. Now you can see, okay, yeah, this is the resource group, and these are all the resources. If you go to the server and you can say PCS cluster status, it says it's having some problem. Now what it says is expected local server name to be this, but it is this. So for some reason, I don't know, basically the cluster, the Linux cluster, it just log into the database and change the server name from local server name into the cluster name. Okay, that is its responsibility to do that. But it says that okay, I'm expecting this, and I got this. I don't know what to do, and erroring out. Okay, so now okay, so now let's start. Now let's stop the cluster. Let's see if it works out. And then set whatever the default configuration options. We are setting the configuration options to use the share folders on both nodes. Okay, so here it is not data log. We have the log folder, right? But it's saying backup. Okay, so I think let's set this here. Okay, I guess the cluster is not running. That's why it is not allowing to set that. Yeah, we will set that parameter later because since the mount points are not there, it couldn't create this one. Okay, now let's set the other ones. Yeah, it's 1433. We don't need to really set this one, but it's no harm setting this one. Let's execute this. Now let's start. And it says this file, this configuration file, just make sure it is the same file on both servers. So you have SQL agent enabled, and then the default log directory is this, default backup directory is this. How about default data location? Default data location. Didn't we set this one here? How about here? Okay, it looks like we didn't set this one. Okay, now we got the default data directory here. Okay, memory is this, TCP port is this. All right, now let's start the cluster. I'm not sure what is the status of cluster now. PCS status, it's not running. Let's start PCS status. Okay, now this time it started. So now we can see here the PCS status. It shows the cluster is Linux cluster, and then The quorum is on this server. There are 2 nodes configured and 6 resources are configured. And then these 2 are online and all the resources are started on SQL CentOS 1. All right, so now if you connect to the cluster, it shows this is the server name. It changed the server name, right? The pacemaker logged into the SQL server and then it changed the server name. But earlier it couldn't change it. It was throwing some error message. I guess let me show you that in the beginning it didn't do proper job. Yeah, here if you see expected local server name to be like this, we don't set that. The pacemaker has to log in and do all that work. Then why are you complaining that, oh, I couldn't do this? I'm now the same pacemaker didn't work back then. Now it is showing, hey, everything is great. I'm able to run this. So I don't know why I always get that error. I don't know how to fix it, and there is no information on the Google. So, but it's running fine. Now it's able to log into the database server and then change the server name to the cluster name. Earlier, you remember when before we create the cluster, I showed you the server name is local SQL CentOS 1. Either you start the SQL service on node 1 or node 2. From both nodes you always see the SQL CentOS 1. Right now it changed to the cluster name. So this is how you connect from application server to the cluster server. Okay, so can you use since the okay, the SQL server is running on this server, this node, SQL CentOS 1. Now can you say SQL CentOS 1? No, oh, sorry. Yeah, you can also connect to the database server from that, using the server name directly, um, and you can connect to the database server. So, but you cannot say connect to the SQL CentOS 2 because the SQL Server service is not running on this server, right? Okay, no, there is no SQL service running on CentOS 2. You cannot, but you can connect like this. All right. Yeah, we successfully installed the cluster, and then let's log into the GUI. Yeah, if you log into the GUI, it shows okay, the resource is running fine, and these are all the resources under this resource group. You have the system databases, this resource, and these are all the disks. These are the file systems, and then this is the IP address, and this is the failover cluster instance. All right, so now everything is running great. If you see here, pacemaker is connected, everything is nice. Now let's see what other things we can do. Okay, so if you run this command, oops, so it shows this is the active server. Okay, if you, when you fail over from node A to node B and you run this command, this one, you will see a SQL CentOS 2. Okay, so now you can create some database. Now it shows the database files are online and it is in this location. Okay, so now let's take backup of the database. We took the backup. Let's take a look. Okay, since the PCS, sorry, the cluster is running on this server, whichever the node that is active, you can see the resources, the mount points on that server. Okay, now you can say, now you can take a look at the database that we created. The log, the backup. So everything is 777 so easy, right? So no permission issues. Otherwise you have to deal with a lot of permissions. Yeah, it's fun to work with Linux with permission specifically. All right, so we have installed. So now let's move the cluster to the other node. Right now we are on CentOS 1. What is the status of cluster? Everything is great. Now let's move the cluster to the other node. This is the command PCS resource move. What is that resource you wanted to move? Resource group. When you move resource group, it is going to move all the resources under that group. Okay, and there is an order in which which resource should come back first and which resource should follow. We have specified all that constraints. Okay, all we need to do is just move this resource group. Similar to Windows cluster. Okay, when you are failing over, you select the SQL role and then you fail over that node to the other node, right? So this is something like that, and in Windows Linux. So now I am failing over to SQL CentOS 2. Now you can see PCS status. I'm just refreshing. Unmount SQL backup. It is not giving up. Oh, okay, see, because you are connected. So you should not be in this folder basically. Since we are in this folder, the cluster couldn't see. It says unmount. I cannot unmount because you are connected to this backup. Okay, so you should not be standing on the tree and cutting the root of the tree. So basically, now it says blocked, right? This one. Okay, it looks like it just failed. Okay, so it shows there is a constraint. So we got to remove that constraint and then let's fail over this time. Okay, now what I'm going to do is probably cluster stop. I'm going to stop the cluster on this node and let's see what is the status. Yeah, it is still stopping the cluster. For some reason I couldn't stop the cluster here, so what I'm going to do is reboot this server. So when I reboot this server from the other node, let's see what is the status. Okay, this time the cluster failed over. I rebooted the SQL CentOS 1 and then it failed over to the OS 2. Now let's fail over back to the OS 1. Let's see what is the status of the SQL CentOS 1. Yeah, now it shows, earlier it was showing both nodes where the SQL CentOS was offline. Now it shows online. So it joined back to the cluster, but I'm not able to connect from SSH because of the network. But now this time we are going to move the services, the resource group to the CentOS 1. See the status. Okay, it started on CentOS 1. Now resource show. So we have set the constraint to be on this server. As long as this constraint is enabled, and this will be the preferred server. Okay, so you have to remove that constraint. Otherwise, if you move the resource to CentOS 2, and then if there is a constraint, again it will move back the services. Okay, so whenever you move, just make sure you clear that constraint so that there is nothing preferred. Okay, so now let's see the status now. It says the 1 is running. Now let's move the resource again back to the 2. Let's see what happens. This is PCS status. Now it stopped the services. Now everything is coming back on the SQL CentOS 2. Okay, so now everything is back on CentOS 2. So that's how you move the SQL cluster from one node to another node. So using this command, move the resource group from to this node. Once you move, you can see what are there any constraints. It says, okay, so move move the resource to this preferred server. So you got to remove that. Okay, and that's how you create the cluster. And these are some of the commands you need to manage. You manage the cluster. So to see the live status of the cluster, so you use this command crm. Probably I'm thinking cluster resource manager monitor, something like that. I think this is the same information that we see in this status. I remember this command because whenever I see the cluster, first thing I do is what is the status of cluster. It is going to show the cluster name, the nodes, the resources, blah blah blah, all the information here. Okay, you don't need to remember so many other commands. But if you have too many resources, then probably you have to use the appropriate command. And if you say show me the resources, it is going to show the resources in this resource group, nothing else. You're not going to see the cluster details. Basically you're asking, show me the resource group. Okay, resources information. And then if you wanted to see any particular resource, you can say, okay, I wanted to see the status or details about this one. So now it's going to show what is this resource and where is it pointing to, and what is the mount point, etc., etc. Okay, so you're going to see all the details here. Even it prints the username and the password here. Interesting. Uh, and then this is what resource cleanup. If there are any errors, this is how you clean up. Okay, so we have seen this PCS constraint show. There are no constraints right now because we just cleared constraint show. There are no constraints. Okay, so this is how you manually fail over to the other node. We just did it, right? And then to stop the cluster, this is how you did it. This is how you do it. When you say stop the cluster, you are stopping the cluster on that specific node, whichever the node you are running on. So right now, the status of the cluster is on both nodes, the cluster service is running, but the cluster is the SQL cluster is specifically running on the node 2. Okay, so if I say PCS cluster stop, it is going to stop the cluster on node 1, node A. Now if you see PCS cluster, it shows, okay, it's offline. All right, so now let's bring it up. PCS cluster start, and then you can see that here it is online. Now PCS cluster stop on this one. Let's see what happens. PCS status. Now you can see the cluster, it is failing over because you stop the cluster service on 112, that is node B. That's why it is failing over to the node A. Okay, when we stop the cluster, it failed over to node A, but then why it is still showing as online? Okay, it just stopped here. Yeah, now it shows it is offline. Okay, so this is a one way of moving the resources from one node to other node. You just stop the cluster, that's it, right? So again, PCS cluster start. This will start the cluster on other node, but it is not going to fail over. You can see that here the cluster is active on these two nodes running, but it is not failing over to node 2 because node 2 is not a preferred server. How do you know it is not a preferred server? If you see the constraint show, it is going to show what is the preferred node. Let's do this. Right now, the resource is running on the node A, SQL CentOS run, CentOS 1, right? Now I'm going to move the resource to the other node like this. So if I say PCS status, it is bringing all the resources on node 2, and then yeah, it brought the services on node 2. Okay, now if I say PCS constraint show, it shows this resource group, it is set to the SQL 2. Okay, now what I'm going to do is I'm going to node B, and I'm going to stop the cluster here, PCS stop cluster, and then see what happens. PCS status, now it is bringing the resource back to the node 1, node A, because node B, the cluster is down, right? That is why it is bringing the resources to the node 1. But what happens if I start the cluster? So what is going to happen to the resources? Is it going to remain on node 1, or is it going to move back to the node 2? See, it is moving back to the node 2, right? I didn't move. The moment I stopped the service, the cluster on node B, the cluster failed over, the SQL cluster failed over to the node 1, right? The moment I start the cluster there, it is again failing over back to the node 2. So why? Because of this constraint. Because of this constraint. That means for this resource group, if the cluster is running on this node, then it will fail over automatically on this node. Period. That's it. Okay, this is like a preferred node. Even this is available in Windows. Whenever you can set in the Windows cluster, okay, this is my preferred node. So whenever that node is available, it just fail over to that node. That's it. Okay, but you need to control as a DBA which node you wanted the resources, right? You don't want resources to be automatically failing over back and forth just because I'm preferred server. So you need to remove this constraint. So that is very important. When you have to, when you move, when you fail over to other node and you see there is a constraint, that becomes like a preferred constraint. So you got to quickly remove it. That's why I just wanted to show you. Now it is running on node 2, right? So now let's say I say this. Now I'm stopping the cluster on node 2. Now it's failing over to node 1, which is expected. Okay, it failed over to node 1. Is there any constraint? There is no constraint. Okay, if I bring the cluster on node 2, will it fail over back to node 2? No, it's not going to fail over back to node 2 because It doesn't have any preference. So as long as the cluster is running on a specific node and there are no constraints, it's just going to continue running on the same node. So you got to be really careful. So when you move, you have to clear that resource. Okay, so this is how you stop the cluster, and you can specifically say, okay, I wanted to stop the cluster on specific node. When you stop the cluster, if you say all, it's going to stop the cluster service on all the nodes. And this is how you start the cluster on all the nodes. And then, if you wanted to update the IP address in the resource, this is how you specify. And to destroy, yep, destroy all will clean up the resource, the cluster on all the nodes. All right, we will look into the add node and remove node next.